Baltimore, United States, 23rd of September, 1940. A squat, doorless car rattled through the gate at Camp Holabird, the Army's vehicle test center in Baltimore. Bantam, American Bantam Car Company, a small automaker, had built this prototype in 49 days, and the Army's hopes rode on it. If it failed, the light scout gap stayed open on the eve of war. If it passed, the test would harden the Jeep, the Army's light 4x4 truck, into a blueprint rivals could not beat. Pre-war Baltimore looked routine. Holabird did not. Its course punished machines with sand, mud, grades, and railroad ties. The Army needed a compact reconnaissance car, small vehicle for scouting, that started cold, hauled a squad's kit, and kept going when roads ended. What survived here set the proportions. Short wheelbase, flat fenders, a fold-down windshield, and controls a recruit could learn fast. The shape fixed that day spread to Willys and Ford production lines and onto every front. This is the story of how it won and why no rival could dislodge it. Baltimore, United States, 23rd of September, 1940. Quartermaster engineers wheeled out scales and gauges as a flatbed from Pennsylvania backed toward the yard. Under a tarp sat a small, unfinished machine and a crate of tools. If it could meet the Army's new standard, horses and motorcycles gave way to a single light truck. By mid-1940, Europe burned. Germany's blitzkrieg had shown what fast, coordinated mobility could do. The United States stayed officially neutral but rushed to rearm. The Army's planners wanted scouts who could move faster than men on horseback and carry more than a motorcycle with a sidecar. The Quartermaster Corps, the Army's supply and equipment branch, issued a call for a reconnaissance car, a small 4x4 scout vehicle designed for speed over armor. The specification was blunt. Four-wheel drive, weight under 1,300 pounds, wheelbase near 80 inches, payload of 600 pounds and road speed of 50 miles per hour. A folding windshield, blackout lights, low visibility lamps for night movement, and towing points were mandatory. Agility dominated the ground rules. The car had to turn tightly and climb or descend steep approaches without scraping its frame. A transfer case, a gearbox that splits power to front and rear axles, had to offer both high and low ranges. The Army wanted a machine that could idle through mud or sprint on a road with equal confidence. The deadline made the request feel like a dare. Deliver a running prototype in 49 days. Major automakers read the weight limit and the calendar and declined. American Bantam Car Company, a small firm in Butler, Pennsylvania, said yes. Bantam's finances were thin. A win meant life and mass orders, a loss meant a dead end. To reduce risk, Bantam decided to use off-the-shelf parts wherever possible. On the 17th of July, 1940, Karl Probst walked into the Butler office. Probst was a seasoned engineer with Packard experience. He sketched a ladder frame, a simple beam chassis, and laid out the driveline and body in days, balancing strength against ounces. Probst's drawings were practical. Flat body panels, no doors, simple seats, and minimal trim kept weight within reach. He specified a compact Continental 4-cylinder engine and matched it to Spicer axles and a 2-speed Spicer transfer case. These were proven components that could be ordered quickly and serviced in any Army garage. The numbers drove the geometry. An 80-inch wheelbase, a touch over 6.5 feet between axles, helped with a short turning circle and a high breakover angle, the clearance over a crest. Short front and rear overhangs improved approach and departure angles so the bumpers would not dig in. Low range in the transfer case multiplied torque for climbs and towing. Meanwhile, the Army sharpened its test pencil at Camp Holabird near Baltimore. Holabird was the proving ground for vehicles, where standard practice took shape. It had a sand pit, mud bogs, steep grades, a water trough, and stretches of railroad ties to shake out loose bolts and weak welds. The goal was to measure, not guess. Holabird wrote procedures that could be repeated across contenders. Scales established curb weight and front-rear distribution. A taped circle measured turning radius. A ramp determined maximum approach angle before a bumper struck. In water, engineers marked the fording line and checked for stalls and leaks. Back in Butler, the clock did not stop. Components arrived hours before installation. Mechanics worked in shifts, fitting axles, routing linkages, and grinding brackets until the sun came up. When the pilot car rolled onto a transporter, the crew packed tools, spare parts, and a list of unfinished adjustments. The convoy reached Baltimore before dawn. Quartermaster engineers readied a notebook of test procedures and a set of gauges to log every run. The stakes reached beyond a small company's balance sheet. If the concept worked, the Army gained a universal machine that could scout, haul, and tow. If it did not, the light scout gap stayed open. What happened next would build a template others would have to match. The gate opened. The gauntlet began. The test began with a stopwatch and a clipboard. Holabird's regimen measured, broke, and measured again until patterns emerged. Every run was timed and logged, from idle pull-offs to wide-open sprints. Inspectors marked chalk lines on tires, slid scales under axles, and wrote down what failed and when. Then the sand pit. The prototype bogged, dug, and climbed out on low range while the timer ran. Mud troughs followed, thick as porridge, forcing slow throttle and steady wheel speed. Rutted lanes, cut to mimic European farm tracks, shook the frame and exposed loose fasteners. Grades tested nerve as much as hardware. A 60% climb, roughly a 31-degree slope, probed traction and cooling on the way up and brakes on the way down. Side slopes near 30 degrees checked stability and seat of the pants confidence. In the fording tanks, 18 inches of water, a foot and a half, set the line for streams and flooded roads. Maneuver tests were clinical. A taped circle captured turning radius. Staggered ramps measured wheel articulation, suspension travel that keeps tires on the ground. Approach, departure, and breakover angles were confirmed against the spec sheets with a steel protractor and a ramp until metal kissed wood. On the paved loop, the little truck had to touch about 50 miles per hour and keep doing it after hard stops. It hit the mark, but repeated braking heated drums and glazed the linings on long descents. On the cooldowns after steep pulls, the cooling system struggled when the engine idled and airflow dropped. The note in the log was blunt, fine underway, marginal at a standstill after a climb. By midday, hardware started talking back. Steering knuckles, front wheel pivots that carry the hubs, loosened under shock from the log road. Axle seals began to weep, leaving thin, oily arcs on the rims. None of it was terminal, but it showed where vibration and pounding found the weak joints. Bantam's crew went to work in the paddock, the service area by the course. They tightened, shimmed, and adjusted in plain view. A shim, a thin spacer to set clearances, took out play in the steering. Holabird permitted iterative fixes during trials, on the logic that a field unit would do the same between patrols. The design's strength surfaced as the course grew harsher. Low-range torque through the transfer case let the truck crawl steadily over logs and pits without stalling. The short wheelbase crested berms without high centering, and the flat belly minimized snag points on brush and rocks. Drivers praised forward visibility. A low hood and folding windshield let them place a wheel on a route and see the next hazard. Towing trials mattered because doctrine asked more than scouting. On level ground, the prototype hauled a 37-gun, a light anti-tank cannon, and its pintle trailer without drama. Clutch smell stayed faint, a good sign. The test notes called fuel use modest for the day, with range on a tank suited to day-long patrols without resupply, a basic demand for dispersed units. Handling trials looked simple but revealed a lot. Under slalom cones and figure-8 patterns, leaf springs, stacked steel strips for suspension, kept wheels planted with predictable roll. Live axles, driven solid axles, took the beating without gear noise or chipped teeth when properly greased. The articulation numbers, recorded wheel by wheel, matched the feel. Enough travel to keep traction, not so much to induce wallow. Weight told a harder truth. Fueled and equipped with tools and a spare, the truck arrived well over the 300-pound target. The Army's original limit, aggressive on paper, met reality in steel. The log added a consequence. If weight climbed, structure had to stiffen. Inspectors flagged the frame for stronger crossmembers to stop the scuttle-shake scene on the log road. Serviceability drew red pencil and praise in the same breath. Blackout lighting controls were praised for clarity by touch. The small silhouette and no doors layout made dismounts quick, a boon under fire. But access to ignition and filters needed work. Mechanics wanted to reach points and coils without scraping knuckles, and to change an air filter without pulling half the cowl. Mud found places humans could not. Open wheels packed slop around brakes and hubs, causing drag and hot smells on the loop after the troughs. Testers recommended easier cleaning paths and shields that shed clods before they baked onto drums. Standardized tool mounts went on the list so crews could carry the same jack and shovel in the same place across all vehicles. The pace of fixes impressed the observers. Bantam's crew swapped parts quickly because the design was simple, with few hidden fasteners and many off-the-shelf components. That speed reinforced a procurement principle that endures. In the field, simplicity beats refinement. Holabir's charts showed the pattern in numbers and notes. The layout worked. Durability would follow with modest reinforcement, not a redesign. By the end of the cycle, the notebook had turned into a blueprint of demands and concessions. Weight limits softened. Structural and service access requirements hardened. The Army's engineers began turning test notes into formal requirements with procurement consequences, and every rival that followed would have to meet the same yardsticks. By the week's end, Holabir's stopwatches and chalk marks turned into a document. Quartermaster engineers compiled the logs into a formal evaluation report that read like an instruction manual for future bidders. It fixed what counted and left little room for improvisation where improvisation cost time. The report reaffirmed the architecture that had survived the course. Front engine, a ladder frame, live axles, leaf springs, and a 2-speed transfer case stayed non-negotiable because they were strong, simple, and easy to repair. The drivetrain could be serviced with basic tools, and the frame took reinforcement without rewriting the design. Key dimensions settled close to the pilot. A wheelbase near 80 inches and a compact track width, distance between left and right wheels, fit farm lanes, forest paths, and railcar decks. Performance benchmarks crossed from notes to rules. About 50 miles per hour on roads, a confident low-range crawl off-road, and a 600-pound payload that equaled a squad's kit or a radio set with batteries. Serviceability moved from complaint to requirement. tool less access to ignition, filters, and the air cleaner went into the text, alongside standardized fasteners where practical so wrenches matched across units. The report specified standardized blackout controls and a consistent dash layout, so drivers could transfer between vehicles without retraining or fumbling in the dark. Feature codification touched the body as well as the driveline. Flat fenders became work platforms for maps, stretchers, or a field stove, and side mounts for a shovel and an axe moved from convenience to standard practice. A pintle hook, a rugged tow hitch for artillery, was mandated for light gun towing and for pulling the standard small trailer. Weight drew the sharpest red line. The allowance rose to about 2,160 pounds, roughly a ton, to buy durability and safety margins after the log road exposed flex and heat fade. The added headroom let engineers specify thicker cross members, stronger spring packs, and brakes with more swept area without breaking the rules that made the vehicle nimble. Holabird drafters turned conclusions into government drawings, official plans for contractors, derived directly from the Bantam pilot. These drawings froze the hard points. Frame rails, suspension pickups, body mounts, and tow geometry. They traveled with new bid invitations so every contender talked to the same ruler and the same holes. Capacity forced the next decision. Bantam could build a few thousand cars per year at most, far short of wartime projections that ran to tens of thousands. The quartermaster chose to solicit parallel prototypes from Willys Overland and Ford using the Holabird baseline, because the nation needed multiple factories, not a single brilliant workshop. Karl Probst's layout became the reference point, and the report said so by what it allowed. Makers could vary engines, gearboxes, and minor bodywork, but not the concept that made the machine work in the field. Procurement shifted from invention to refinement. Build to the baseline, prove reliability, then scale as fast as the supply chain allowed. Language changed in parallel with the hardware. In paperwork, the Army often used general purpose, truck to class the vehicle. In the yards, the slang Jeep already existed for new gear and raw recruits. Holabird tied the nickname to this car as mechanics and drivers repeated it through the week until it stuck to the silhouette. An immediate outcome followed on paper and in steel. The Army placed a 70-vehicle pilot order with Bantam for field trials across units and terrains, from mountain posts to coastal bases. Those trucks would feed back repair data, parts wear, and driver notes that either confirmed the baseline or nudged it before mass production. Holabird's process rewarded parts that existed in quantity, not bespoke pieces that choked assembly lines. A standard starter, a catalog axle, a common carburetor meant spares on the shelf and second sources when one supplier fell behind. That discipline, more than any single feature, set the stage for a universal machine that industry could actually build. With a baseline set and drawings in hand, the center of gravity moved. The next prototypes from Toledo and Dearborn would be judged against a yardstick, not around it, with the stopwatch and the ramp deciding what survived. The contest shifted from, what is a Jeep, to, whose Jeep lasts longest at war speed. Holabird's baseline changed the contest from invention to discipline. The raised weight limit bought strength, but it preserved the core. Short wheelbase, low hood, and a 2-speed transfer case. Government drawings froze hard points, so later bids had to fit the same holes and deliver the same tasks. Novelty gave way to proof at the ramp and stopwatch. Standardization followed in steel. Willys built the MB. Ford built the GPW under license to the Willys pattern, and most major parts cross-fitted. The ordnance catalog tagged the type as G503, supply code for the 1/4-ton 4x4 truck, which aligned parts lists across makers and depots. Controls and fittings matched by rule, so a driver who learned in Toledo could climb into a Dearborn-built truck without a second thought. The field was the final exam, and the layout made sense to mechanics. Leaf springs, live axles, and simple gearboxes could be stripped with basic hand tools in a roadside bivouac. Open bodywork and flat panels cut production time and made battle damage repair practical with a torch, a hammer, and sheet steel. Units bent fenders back into shape, riveted patches, and went on. Holabirds' course had valued tractable low-range torque, not peak horsepower, and the production driveline delivered it. The Willys Go Devil 4 produced about 60 horsepower but, more importantly, roughly 105 pound-feet at modest revs. Through low range, that twist let the truck climb grades, idle across ruts, and tug a 37-gun without drama. Drivers learned to trust steady throttle more than throttle stabs. Size finished the argument. The compact footprint fit hedgerows, jungle tracks, and European village streets where wider, taller machines hesitated. Shipping favored it. More units per ship, railcar, or cargo deck meant more mobility at the far end. Gliders like the carried a jeep and a team into small fields. On landing craft, crews packed dozens up the tank deck without wasting space. The baseline's tow and carry mix proved decisive for jobs beyond scouting. The 1/4-ton rating and stout pintle let one platform haul wire reels, radios, or a light gun, then switch to liaison or ambulance duty with stretchers lashed across the fenders. Kit standardized how to bolt on a winch, a wire-laying reel, or a deep-water fording stack, all without reinventing the vehicle. One chassis handled many roles because the fundamental geometry and power flow were right. Rivals showed the penalties of other choices. Heavier scout cars with armor bought protection but lost agility, transport density, and fuel economy, which mattered when ships, rail, and jerrycans were scarce. Enclosed bodies came with weight and complexity that slowed repairs and trapped heat in the tropics. Motorcycles and horses remained nimble but could not tow, stayed unstable in mud, and demanded weather and fodder the Jeep did not. By privileging measurable tasks, climb this grade, ford this depth, tow this load, Holabird stripped preference out of procurement. Comfort, chrome, and odd layouts died on the first slope or in the first mud trough. The baseline exposed costs every commander understood. A heavier frame meant fewer vehicles per ship. A thirstier engine meant shorter patrols or bigger fuel trains. Numbers settled arguments faster than memos. Scale sealed the outcome. About 640,000 wartime Jeeps were built, a figure no rival class reached. Roughly 360,000 came from Willys and about 270,000 from Ford, with Bantam delivering a small early run before moving into trailers. Lend-Lease pushed around 50,000 to the Soviet Union. Others spread across North Africa, Italy, Burma, and the Pacific Islands, where the same silhouette did the same jobs with the same spares. Training mirrored production. Motor pools could swap a dead MB for a GPW without retraining a driver or rewriting a manual. Parts interchanged by stock number, and the dash layout was constant enough that night driving on blackout lights felt familiar in any theater. Logistics tightened because the machine stayed the same. The result was a true universal, not because of marketing but because a test matched mission to design and locked it in. The rivals did not vanish. They simply lived on the margins where their strengths mattered. The image that endured was small and square-jawed, a truck that did many jobs well and kept doing them wherever it landed. At Holabird, a hurried Bantam prototype met a hard standard and proved the layout. The Army turned stopwatches and chalk marks into a baseline others had to follow, then froze its hard points in government drawings. Willys and Ford built to that pattern and kept parts interchangeable, and the small 4x4 spread by the hundreds of thousands, while rivals lived on the margins. The same squat car idled out of Holabird, smaller than its legend, but already fixed in form,